Thank you, Sir Jordan. Magandang hapon sa lahat. So today, just piggybacking from Sir Mike's introduction, so I'll talk about generator sizing, siting, and network interconnection. Okay, so if you look at the first volume of the Philippine Energy Plan, it's already published by DOE. So we look at the capacity expansion plan. Ito yung sinasabi ni Sir Mike kanina that the DOE gives us what the generation mix will look like 10 years, 20, 30 years from now. So from this plan, we see that demand quadruples, no? From around 16.5 gigawatts for the entire Philippines. By 2050, we will be at 68.4 gigawatts. So that's 4 times increase in peak demand. So to cope up with the demand, the DOE projects that we need to add around 122 gigawatts or 122,000 megawatts of power plants by 2050. Okay, so that's around, we're currently at 28.2 gigawatts, so that's almost 5 times more. Okay, so the question really here is, we know, well, the DOE projects what technologies these power plants are, how many, how large, but where do we place them in the network? Okay, so generation expansion planning is basically a process used by energy planners like the DOE and other utilities to find the optimal or the least cost configuration of the power generation. Nawala yung screen. Ayan. Okay? So the optimal power generation mix that meets future demand. Okay? So that's conducted by the DOE, and that's part of the Philippine Energy Plan, as I mentioned. So optimal new capacity is aggregated per technology, okay? Meaning X megawatts of natural gas by 2050, we need X number of coal or X number of solar plants by 2050. Okay? And also, what's important here is, Sir Mike mentioned earlier that there are multiple scenarios. There are clean energy scenarios where we need to, the DOE tries to simulate what if, or we must adhere to these targets. No? For example, the National Renewable Energy Plan states that by 2030, which is just 6 years from now, we need to have 35% generation coming from renewable energy. Currently, we are at around 22%. Okay? And by 2040, we need to be at 50% renewable energy in the generation mix. So plus, there are also policies like the moratorium on coal power plants, meaning no new coal plants are allowed to enter the grid. And then there are roadmaps for battery storage, offshore wind, and nuclear. So all these policies are integrated into these capacity expansion plans. So to integrate this plan, this capacity expansion plan into the transmission network, we need to disaggregate all these generators. Okay? So this is the general process that we did for generator siting, sizing, and network interconnection. Okay? So if you look at those in color blue, those are from the files from DOE. Okay? So we have the service contracts, the competitive renewable energy zones, most importantly, the capacity expansion plan. So yung nakita niyong graph kanina, that has all the generation mix every year by 2050. And then we take all this data, since the disaggregation of these power plants are spatial or geographical in nature, we leverage the use of GIS, or Geographical Information Systems, which I will discuss earlier. So we site the generators, but before we do that, we need to also size them. Say, for example, the DOE says, or the capacity expansion plan says, we need 20,000 megawatts of natural gas by 2050. So that's the number they give us. So the question is, where are these natural gas plants need to be placed, and how large are they? Okay? So we need to break them down into unit sizes. And after the generator sizing and siting, then we place these generators in their appropriate places. And then the next step is, of course, they're just generators in a certain area. They need to be interconnected to the network for us to do the transmission expansion planning. Okay, so these are just some maps. So I mentioned the spatial nature of disaggregating technology. So if you see on the leftmost, that's CREZ. That's a study published by NREL with DOE. So Sir Mike talked about this. So this just details where the solar, wind are more probably best located. And then we have also the transmission network from NGCP and Transco. And then on the right, this is a new study published by the World Bank, where best to place offshore wind. Okay, so we see a lot of new areas there, like Northern Mindoro, Southern Mindoro, and Guimaras. Okay, so we need to integrate all these maps into something that we can use to site these generators. Okay, so we start with sizing, kasi of course, as I mentioned, napakalaking capacity expansion plan, it's hard to distribute them. So the capacity expansion plan is aggregated per technology, so we need to break it down to typical units sizes. Okay? So unit capacities will facilitate easier disaggregation of the generators. So we have this list that we coordinated with DOE on what the typical unit sizes are. Okay? Of course, historically, we see different sizes of coal, units of natural gas, but we agreed on a certain typical unit capacity. So for example, if there's 2,000 megawatts of new natural gas to be sited, and we assume that a typical unit size of natural gas is 418 megawatts, then we have around 4.785 units to site all over the grid. Okay, so we can have combinations of 4 by 418 megawatts or 1 by 328 megawatts. Another example is if the capacity expansion plan says we need to have 575 megawatts of new hydro run-off river, and we assume the typical unit size of hydro ROR is 5 megawatts, so we have 115 units to scatter around the network. Okay? So once we have that number, how many units do we site? How many solar units do we site? How many battery storage units do we site? We need to look at generator siting. So each generation technology has its own set of what we call siting criteria. Okay? So for example, for RE, there's your resource potential, of course, where the wind blows best or where the sun shines best. We also look at already awarded service contracts. Because in the DOE, before you can put up a solar plant or a wind power plant, you need to apply and be granted a service contract. So this list of service contracts that the DOE gave us gives us an idea where the investors want to put up. Of course, before they put in money or apply, some of them already have done their own feasibility studies or resource assessment studies. Another information that we looked at are, for example, for hydro, of course, the priority areas for hydro will be rivers, reservoirs for our dams. Okay? For our conventional, the coal, natural gas, and nuclear, we need cooling. So we need proximity to water. These plants are run very hot, they need water for cooling. And also, ports, because most of our fuel is imported. So easier access to ports, to seaports, will allow for better efficiency in logistics. Okay? Another thing that we look at for conventional is just look at where the current power plants are. So we have a lot of them in Bataan for coal, and we have a lot of them for natural gas in Batangas. So maybe that's a good place also to distribute these generators. So every municipality in the Philippines we look at. We look at against these criteria, and heuristically we assess them. So for example, one municipality, you see the maps here, this is one of our preliminary outputs. So the colors there are different criteria. So one municipality can tick off 3 criteria in a certain technology. For example, for coal, it might be, that municipality might be near water, might have a seaport, and it might have already an existing coal plant there. So there's a high chance that we can place these new coal units there. So we use a combination of GIS, as mentioned, mapping, and spreadsheet tools to facilitate generator placement. Okay? So once we place the generators or over the network, of course, we need to interconnect them to the grid. Okay, so each new sited generator will be placed in GIS again, and then we overlay the transmission network. Okay, so this is something that we took from what Transco and NGCP had, but we translated it into GIS because there was no readily available GIS form for the transmission network. And one by one, all the generators that we have cited, we need to determine which is the best connection point. So we considered factors such as substation type. No? Hindi necessarily siya yung pinakamalapit na substation, pwede na siyang kumonect doon. Because sometimes, some substations are utility-owned or even generator-owned. And you may already know that the Philippine electric power industry is already privatized. So each substation might have its own owner. Okay? So we also considered voltage level. So for larger generators, we tend to connect them to higher voltages, 230 kilovolts, even 500 kilovolts. And those with lower capacities, we assign to 69 kV and even lower voltages. Okay? So that's the entire process. We repeat that for each grid, for Luzon, for Visayas, for Mindanao. And then we do that again for the other scenarios, the clean energy scenario 1, the clean energy scenario 2. So that's a lot of work that the team is currently doing. Okay, so to summarize, we are given a capacity expansion plan that are aggregate numbers. We size the generators, and then we site them in the network using heuristics, and we use GIS to facilitate this. And then the main output will be the network. Now, the electricity network, for example, by 2050, with all the new generators already connected. This is the sample output. I did not label it for since this project is still ongoing. But you see the transmission network and then the generators where they are sited. So this model will be then forwarded to the next step for the transmission expansion planning. So that is all for my talk. Maraming salamat po.
Again, we welcome questions from the audience. Please feel free to approach the mic at the back. So let us award this certificate of appreciation Mr. Luigi Teola for sharing his presentation on generator sizing, siting, and network interconnection during NEECECON 2024.